Good morning to all. I'm Ankita Agarwal from IT Department, Acropolis Institute of Technology and Research. I'm here with the topic linear regression in machine learning. First of all, let us try to understand what is linear regression. So linear regression is the easiest and the most popular machine learning algorithm. It is a statistical method that is used for the predictive analysis. Now, linear regression practically comes into existence where we want to predict the sales of certain commodity or the salary of the employee or the age of a person or the product price of any of the item or the commodity. Now, how these are classified as this is a data which is having integer values or the floating point value. So linear regression can be applied to those data only where we have the continuous data. Now we have the two type of data, that is first continuous data and second is categorical data. Continuous data is the one that has the numeric value. That means it can have the value as integer value or the floating point value. Secondly, the categorical data is the one in which we have the output as few of the categories. Like if you want to classify sample population into males and females, or we want to classify number of things into few colors like RGB model, so that comes into the categorical data. Now linear regression shows a linear relationship between y and x where dependent variable is y and independent variable is x. Since the linear regression shows a linear relationship, it means it finds out the value of the dependent variable is changing with the help of the independent variable. The linear regression model provides a sloped straight line representing the relationship between the variables. Now let us see this graph. What it is trying to indicate is on the x-axis we have the independent variable and on the y-axis we have the dependent variable. The black colored line is a line of regression, the bold line, and the blue colored dots are the data points. Now what this line is trying to indicate is that how many data points are falling on that particular line of regression. For the best fit, the data points must not be scattered on a larger area. It must be on the line of regression or near somewhere to that line of regression. Now coming to the next thing, that linear regression models a relationship between dependent and the single independent variable. So that is why it is called the linear regression. Now if the independent variable are more, then it will come into the consideration of multiple regression or the polynomial regression. Now with the help of linear regression, we have two main objectives. So the first is we model the relationship between the two variables. Like if the example we are taking is income and the expenditure, or the experience of the employee with the salary, or we are trying to forecast some new observations like weather forecasting according to the temperature, revenue of the company according to the investments in a year. These all come under the simple linear regression in machine learning. Mathematically, it can be explained with the help of the equation y is equal to a0 plus a1 x and plus e. That means a0 is the intercept of the linear regression line, a1 is the slope of the linear regression line, and e is the error term. For the good model, it will be negligible. The same equation can be explained with the corresponding equation as y equal to mx plus c. Now we are moving towards the implementation of simple linear regression algorithm using Python language. So the problem statement example consists of two variables, that is salary and the experience. Salary of the employee plus the experience of the employee. Now salary is a dependent variable, experience is an independent variable. How the experience and salary are classified as dependent and the independent variable are as follows. Like the experience of a employee will be stagnant, means that cannot be changed, but salary will vary with the help of that particular experience. Like suppose if a person is having 2 years of experience, his salary will be different with the person having the 10 years of experience. So this is how what we are trying to find out from this problem statement is we are trying to find out the correlation between the salary variable and the experience variable. And secondly, what we are trying to do is a best fit line for the data set. And the third thing that we are going to see with the help of this data is how the dependent variable is changing with the independent variable. So firstly, for moving towards the implementation, first step is data pre-processing step, also called as exploratory data analysis. So in this first step, data pre-processing, what is data pre-processing? Actually, it is cleaning up of the data. Now, why the cleaning up of the data is required, as we have the data in which a number of not required things are there. Like in the pre-processing, first we will import the data, then we will look for the null values, if there are any null values, and what we must do depending upon the data in the problem statement. It must be dropped, or it must be replaced with the help of any of the central tendencies like mean, median, mode. So those things come into the EDA step. Another thing that comes into the EDA step is a outlier detection. So if there is any outlier detection, then we with the help of the box plot, we can know about the outlier, or the Voilin plot can be used for the same. And then we remove the outliers. So firstly, we are importing the library NumPy as NM. Secondly, matplot.pyplot as MTP. Thirdly, pandas as PT. For the data variable that I'm using here is data underscore set, in which I'm reading the file salary data underscore data.csv. Now from this, I'm dividing the whole data into x and y variables. So in the x variable, I've taken it as years of experience, and y is salary, which can be visualized in the form like this. So I have put the values of x and y variables. Now, total number of observations, or the number of rows in our data set, is 30. Now, what we are doing is trying to divide that data set into the training and testing. So with the sklearn.model selection, we will import the train test split, and from that we will divide the data into the training and the testing with the help of test size and random shift. Test size here I have taken it as 1/3. It can be taken it as 70% of the data, 70/30, 60/40, like that. And the random state can be taken it as a 0, 1 or 42, depending on again on the nature of the data set. Now we are trying to fit the simple linear regression model regression to the training set. What we will do with the for this, from the sklearn library, again the sklearn library, from that we will import the linear model, and from there we will take the linear regression. If we are working on the logistic regression, we will change here in the linear regression into the logistic regression. Now regression, in that we have taken as linear regression. We are trying to fit x and y arguments into the fit method. Now after doing that, we are predicting the test set results. Now dependent is salary, independent is experience. Now our model is ready to predict output for the new observations. Here we can predict the new observations with the help of this model. Now prediction of the test and training set results are as follows: y predict and x predict. In the y predict, we will be passing as x underscore test as the argument, and in the x predict we will be passing the x underscore train as an argument for the predictions. Now lastly, what we are trying to do is visualizing the training set results. Now whatever we have taken the training data, we are trying to visualize that with the help of the scatter plot. Now scatter plot will give the data points in the form in which the data points are scattered in a certain area. So for that we are using the first line of the code, that is mtp.scatter. In that we have passed the x train and the y train. Color of those data points, we have taken it as green. Secondly, we have taken it as plotting that line, the red color line. That is, in that what we are taking an argument as x underscore train and y underscore prediction. Then title is used as the salary versus experience. Then on the x-axis, what the title we are using is, with the help of x label, is years of experience, and on the y-axis we are taking it y label as salary in rupees. With the help of mtp.show, we will show the result. Now same way we are trying to visualize the test results. So Again, the code goes in the same manner. Here in the scatter, we will take the X test and Y test because we are trying to take the visualization of the test results. And in the plotting, we have again taken it as a red colored line, in which we have taken X train and X prediction there as a argument. Again, the title is salary versus experience. X label is years of experience. Y label is salary in rupees. And with the help of mtp.show function, we are trying to show this. This is how the linear regression in machine learning works. Thank you.